Section 5.5, Solving Application Problems with Proportions. So the previous two sections we've been working with proportions. In this section we're going to actually solve some problems using proportions. Okay, so like any word problem, there's some steps involved, and let's just kind of take a look at these. So the first thing, and this seems kind of silly to say this, but you got to read the problem, and by reading it means that you understand what you're being asked to do. If you don't understand the problem, you can't solve it. So read it carefully, be sure you understand what you're being asked. Once you understand it, you can then work out a plan. In this case, recognize that the problem can be solved using proportions, and you want to set up your proportions. Once you set it up, you should be able to look at it and say, okay, what would be a reasonable answer? What would I expect a ballpark figure to be, so that when you get an answer, it should jive with what you estimated. Then you go ahead and do the actual math, you solve the problem, and then once you solve it, state your answer to be sure that you have in fact answered the correct question. And then finally check your work. Does your answer coincide with what you estimated it to be? And then you can do the formal check. Okay, so here is an example problem. Let's go ahead. Step one is read the problem. So on an assembly line, James can process 30 circuit boards in 108 minutes. At that rate, how many circuit boards can he process in 252 minutes? Okay, so reading this, I understand there's a relationship between circuit boards and time. So here's my circuit boards, and here's my time in minutes. Okay, and then they ask about the number of circuit boards given a different amount of time. So I understand that this problem can be solved with proportions. So once I've read the problem and I have a plan using proportions. So let's go ahead and write the proportion. Now there's a relationship here between circuit boards and time. So I'll make that my rate. So 30, and since it's a rate, I got to include, I'll just use CB for circuit boards. I got to use my units, and then I have 108 minutes. Okay, since it's a proportion, I've been given some other information. Well, here they're asking how many circuit boards can be made. Well, since circuit boards are on top, that will be my unknown value, or my X in this case. And then the amount of time was 252 minutes. Make sure that your units are on the same side of the fraction. Minutes are with minutes. In this case, circuit boards will be with circuit boards. Okay, so that's my plan. Now let's estimate a reasonable answer. Well, if I take a look at this, if I start with 108 minutes and I go to 252 minutes, I've basically slightly more than doubled the amount of time, which means that I should slightly more than double the 30 circuit boards. Well, if I double 30, that would be 60, but it's going to be more than double. So a reasonable answer would be, 68. Okay, and again, I'm just guessing, but that would be a ballpark figure that I expect to get as an answer. Okay, once I have estimated, I then go ahead and solve the problem. Okay, since it's a proportion, we're going to go ahead and do the cross products and set them equal to each other. So I'll go ahead and start here with the X. So I have 108X is equal to, and then I'll take the cross product of the 30 times 252, which is 7,560. And again, you're going to be using a calculator. Okay, since it's a proportion, cross products, I now divide by the value that is with the X. So on my calculator, when I do that, I get an answer of 70. Okay, so I've solved the problem. State the answer. Well, let's just make sure I'm stating that there's going to be 70 circuit boards in 252 minutes. Okay. Does that make sense? Well, I estimated that it's going to be somewhere around 68. The actual answer is 70, so it does coincide with what I expected as an answer. So informally, I feel pretty confident that my answer is correct. However, you can check your work by plugging 70 back into the proportion, doing the cross products, and making sure that they equal each other. I will leave that to you as an exercise. Let's look at one more problem. Okay, step one, read the problem. Okay, so 2 pounds of grass seed covers 475 square feet. How many pounds are needed for 5,700 square feet? Okay, I understand the problem. There's a relationship between the amount of grass seed in pounds and how much it covers. So I'm going to work out a plan. Since there's a relationship, a rate, I'm going to use a proportion to solve this. So let me go ahead and set it up. So I have 2 pounds, and again, since it's a rate, I need to keep those units, is related to 475 square feet. And it's equal to, and they gave me the square footage. Since square footage is on the bottom, I will keep that in the same location. And they're asking, well, how many pounds of grass seed would it take to cover 5,700 square feet? So that's my unknown. Okay, now let's just estimate an answer. Well, if you take again a look at the bottom figure, since they both exist, multiplying something by 10 just adds a 0. So I can see that if I multiplied the bottom here, the 475 by 10, I would get 4,750, which is still less than 5,700. So this is going to be slightly more than 10 times the amount. Well, 10 times 2 is 20, so a little bit more than 10 times. I would just estimate something to be, and again, I'm just estimating, I'd say 22 pounds of grass seed is a rough estimate. Okay, now that I've estimated an answer, let's go ahead and compute the correct answer. So the first thing we do, since it's a proportion, is do the cross products. So 475 times x, here's my cross product here. Now cross product here, well, 2 times 5,700 is 11,400. Okay, cross products, I'll now divide by the number with the x, which is 475 on both sides. And when I plug that into a calculator and do the division, I get an answer of 24. Okay, so I have solved the problem. Now I state the answer. Let's just make sure I've answered the correct problem. Yes, it would take 24 pounds of grass seed to cover 5,700 square feet. Okay, check my work. Well, my estimate, again, this was just a rough guess because it was more than 10 times, was 22. My actual answer is 24, which is very close, so that's a reasonable answer. And then you can formally check it by plugging the 24 in for the x and checking that the cross products are equal to each other. I'll leave that as an exercise. That concludes this section.